Write the polynomial in factored form, 8x to the third minus 162x. Whenever we're factoring our polynomials, we want to see, is there a greatest common factor we can divide out from all the terms in the polynomial? And here, if we look, we can see that both terms have an x, so we could divide that out. And we also have some numbers that we could divide out here. They're even, so I think we can divide out a 2. So if we're dividing out a 2 and an x, that would leave us with 4x squared minus 81. So again, looking at our polynomial here, we want to see if we can break it into more basic components. Can we factor the quadratic polynomial? Well, we can see that we're missing our linear term, so sometimes you like to write it to show that you're missing that linear term. And we can follow the quadratic pattern that we've done in the past, the leading coefficient times the constant. So what times what gives us negative 324, and what plus what gives us 0. So thinking about those combinations, we could use 18 and negative 18. We can rewrite the polynomial with 4 terms using those. So we would have 4x squared plus 18x minus 18x minus 81. Again, with 4 terms, you would like to look at them in pairs and see what's the most you can divide out from each pair. So I'm looking at these two here. Can definitely divide out an x and a 2. Here, we could probably divide out a negative 9. So again, looking at them in pairs, dividing out what we can. We can see each term is being multiplied by 2x plus 9. Well, what's being multiplied by 2x plus 9? 2x minus 9. So let's look to see what components we have for our factored form. We had our greatest common factor of 2x. We also now have 2x plus 9 and 2x minus 9. So this would be our completely factored form for our original polynomial. There is another way that you could have factored your polynomial. Going back to your greatest common factor, again, if we saw that it was our quadratic and we're missing the linear term, we can think about where that came from. Now, 4x squared, we know x squared comes from x times x, and 4 comes from 2 times 2. 81 comes from 9 times 9. So if we think back to the components, like we kind of did for the cubic, because it was only the 2 terms in the polynomial, we can see if that helps us. This is what we call a difference of squares, because each element is something times itself. They're perfect squares. So if you notice that it was a perfect square, you could have used the elements to write it in factored form. Because we need a 0, 1 would have to be an addition and 1 would have to be a subtraction. So you could have went straight from your greatest common factor to your factored form if you had noticed that it was a difference of your squares. And you could have used that pattern to help you. So again, you had 2 options on factoring your polynomial based on the patterns that you saw.